So 43 said, a table has the side measurements. A table has the side measurements, sides that measure 3x squared. So anytime you have something that is a picture that it would be good to see, you're going to draw it. All right, well, since it says the side measures are 3x squared, that tells me, because it said the sides are that means that I have a square. So here is my table. The sides are 3x squared, feet. Write an expression for the area of the tabletop. How do I find the area of a rectangle or a square? How do I find the area of a rectangle or a square? Dominic? Name times width. Or if it's a square, what else could I do instead of length times width? Layla. Length times length, or length, Instead of length times length, we could say length to the second power. So you could have used either one of those. I am going to show you both, because one of them uses power rules that we did last chapter. The second one uses power rule that we're doing now. All right. So you have to write your formula down. Every time you have a formula, you have to write it down when you're using it. Or if I use that first one, I have 3 squared times 3 squared. This required that you go back in your memory bank or your notes if you needed to on multiplying 2 numbers with the same base. All right, so everything here, Frankie, is multiplication. So I'm going to move my 3's next to each other. I'm going to move my x squareds next to each other. Well, 3 times 3 is 9. All right, when I'm multiplying 2 numbers with the same base, I keep the base. What do I do with my exponents? Aaron, you add them. So this is 9 to the 2, 9 times x to the 2 plus 2. So this is 9x to the 4th feet squared. Always put units on these. All right, I'm going to put or here. If I used length squared, this is applying more of the power rules that we did. Applying more of the power rules that we were doing last night. All right, so if I decided to use length squared, it would be 3x squared in parentheses squared. All right, using our power rules we did last night, what do I do from here? Jack? So tell me what I'm going to write, sweetie. Excellent. Excellent. I have to see that. So now I end up with 3 squared times x to the 4th, which we know is 9x to the 4th feet squared. Area is always squared. Yes. Add back in what? What are the dimensions in? What are my dimensions in? What are the dimensions being measured in? Frankie, what are the dimensions being measured in? Feet. What is area? Isn't area always squared? That's why it's feet squared. I have to have units on this. This is my area. So if I said x is, let's just say for the sake of argument, I told you x was 2. So I would do 2 to the 4th power, which is 2 times 2 is 4, times 2 is 8, times 2 is 16. I would do 16 times 9, which is 116, I think, feet squared. So it's not that I'm just adding them back on. That is what area, the length and width are being measured in feet. I'm finding the area, so it's feet squared. What else can I do for you guys? Christiana. 28. Alright, 28 said, I have in parentheses negative m over b to the third, all raised to the sixth power. Is this the one you're talking about? Alright. You guys, when you have a negative fraction, that negative goes on the numerator or the negative goes on the denominator. Now, because I have b squared in my denominator, that's going to make things more confusing if I throw an m on there, or a negative on there. So I'm just going to put the negative on my numerator. Alright, this just means, if you're not sure what this means, what this actually means is, it means negative 1 times m over b to the third power, all to the sixth power. That's what negative m means. And it means negative 1 times m. Alright, so if, I'm going to write or here. On that first one, I would do negative m to the first times 6 over b to the 3 times 6, which is negative m to the sixth power over b to the 18th power. Now, I'm good with you leaving it like that. My guess is this was our answer. I'm going to distribute that power of 6 to my negative 1, to my m, and to my 3b. So this would be negative 1 to the sixth power times m to the sixth power over b to the third times 6, which would give me, well, a negative 1 times itself 6 times, well, that's an even number of times I'm multiplying together. So they all have a partner. So all my negatives have a partner, so my answer is going to be positive. So this just ends up being a positive 1 times m to the 6th over b to the 18th. Alright, and my guess is that's probably the answer they gave me. Alright, so that's why I would have taken this just because we hadn't really talked about that negative out in front. But when we have a negative in front of something, in front of a variable, that just means it's negative 1 times that variable. So this is what we needed to focus on, was that. Alright, what else can I do? Kira? Yes. It might be. So write it down. Anything that we go over is possible for anything on future homeworks. Which is why you're all writing it down and you're all asking questions if you don't understand it. So anytime we have a negative out in front of a number or a negative out in front of a variable, it's always negative 1 times that. When it's a number, it's just negative 5 to the 5th power. So negative 5 times negative 5 times negative 5. It's when it's a negative 1 negative in front of the variable that kind of throws us off. But that's negative 1 times that variable. Frankie? Alright. You know, you guys, I want to do harder ones. So, you guys need to come see me if you have any more questions on last night's homework. I want to get to new ones. So get your notes out. Frankie, 42 is exactly like 43. I already did 43, so go back to 42, okay? And see if 42 can help you with 43. All right, today's the 11th. I want to practice the distributive property of powers rule. Alright, so you guys have, on that first page, 8-4, you guys have 1 through 15 odds. So I'm going to do number 6 to number 14 for you. So this is from worksheet 8.4, and this is number 14. Please make sure you're taking good notes on this, so you can use these as a guide when you're doing tonight's homework, because these are harder problems. This is our 8th grade book. Okay, so this is what I have. A to the third times b to the fourth in parentheses. That is all to the negative second power. So we're going back and using all of our power rules here. Times, in parentheses, a to the negative third, b to the negative fifth, all raised to the negative fourth. Okay, how many of you are like, wow, that looks really confusing? Okay, everything here is being multiplied. How many of you guys understand that? I mean, we have powers here, but everything else is just being multiplied. So what I want you guys to do is, I want you guys to think about taking care of that first set of parentheses first. So, this is simply our distributive property of powers on that first one. So this is a to the third times negative 2 times b to the fourth times negative 2. Jack, what's up? Then just write what I have there. Questions so far? Okay. Well, what is a to the 3 times negative 2? Alex? A to the negative 6. What's my b? B to the here? Negative 8. Are you guys cool so far? How many of you guys are all good? Okay. Now, I'm just going to do that second part. Again, I'm going to do the distributive property. If you notice, I'm not separating these apart. I'm doing them in the same format. This is all being multiplied together. All right? So, times, I'm going to put a little times here. Well, a to the negative 3 times negative 4. B to the negative 5 times negative 4. All right? So, in my next line, I'm just going to kind of put it next to it here. So down here, what's a to the negative 3 times negative 4? Christiana? A to the positive 12. What's b to the negative 5 times negative 4? Christiana? Excellent. Now, I need to simplify that. All right, so I need to simplify. Now, all I'm going to use now are my power rules where I'm multiplying two numbers with the same base. So I'm first going to move my like terms next to each other. So this is going back to what we did in the last chapter. So I'm moving my like terms next to each other. Now I'm going to use my power rules where I'm multiplying two numbers with the same base. Well, if I'm multiplying two numbers with the same base, what do I do with the exponents, Romano? You add them. So I have negative 6 plus 12. So that's a to the negative 6 plus 12 times b to the, Mia? Negative 8 plus 20. So, what is negative 6 plus 12? Mateo? So I have a to the 6th times b to the, Alex, 12. That's it. All right, let me do another one for you guys. Can you guys see how we've kind of put a bunch of these power rules together? We've had to use several of them. All right, once I broke that down and kind of covered up that first set of parentheses, how many of you guys are like, oh, I totally can do this? Okay, that's what I want you guys doing. Let's do a division one real quick. So I'm going to do number 12 from worksheet 8.5. Again, please use this as a guide. Number 12 said in parentheses, a squared times b to the negative 4th divided by b squared. Now you have to keep in mind, you're seeing negative powers. So once I get done doing my distributive property, simplifying where I can, you've got to pay attention, what do I do if I have a negative power at the end? All right, this whole thing is going to be raised to the 5th power. Keep this in fraction form. Please keep it as a fraction with a horizontal line as your fraction bar. It's going to make things a lot easier. I'm going to go ahead and do my distributive property of powers. So I have a to the 2 times 5, b to the negative 4 times 5, over b to the 2 times 5. So this is just doing our distributive property of powers. What is my fraction going to look like after I do the multiplication? Layla? Okay. Over b to the 10th. Okay, now I can go ahead and simplify those b's. So this is going to be a to the 10th. I'm leaving it. All right, I'm dividing two numbers with the same base. I keep the base in the numerator. What do I do with my exponents? I keep the base in the numerator. What do I do with my exponents? Addison? Nope. I keep the base in the numerator. What do I do with my exponents when I'm dividing two numbers with the same base? Angela? You subtract them. It's your numerator exponent minus your denominator exponent. Addison, what I could have done was move that negative power into the denominator and then done b to the 10th times b to the 20th in the denominator. That is another way that you could do it. Okay. All right, so from here, I have a to the 10th times b to the negative 30th. What do I have to do when I have negative exponents? Because it's not simplified if I have a negative exponent. What do I have to do? Mateo? Yep, I need to move that b to the negative 30 to the denominator. So this is going to be a to the 10th over b to the 30th. Yes, Mia? Well, because I have negative 20 minus 10. And if I do adding the opposite here, it's negative 20 plus a negative 10, which is negative 30. So make sure you're watching that subtraction. All right, always do adding the opposite. All right, so you have two here for you guys to go from, all right, that are a little bit harder, like some of the ones that are going to be on here. So this is making you go back to some of your old power rules. Are you guys cool? All right, you guys can go. Again, that